students, welcome back. This is Taura's Elbow Bump. How are you? Are you doing okay? Is your family okay? Remember, if you need anything, just shoot me an email and I will try to help. So lucky you, you get to hear my voice for another lecture, but the best part is we're going to continue working with the 5-number summary and start working with box plots. Yay! As a review, last chapter we talked about how mean, median, and mode tell us how the data is alike. We need the data to be sufficiently alike so that we're drawing from the correct population. Measures of variability describe how the data is different. We need the data to be different enough for us to find if there's a difference between what we're studying and what was in the original population. There are commonly used measures of variability. In the last video, we talked about range. We talked about interquartile range. We talked about how to find the 5-number summary, which is the minimum, the lower quartile, the median, the upper quartile, and the maximum. And today we're going to start talking about how that's related to box plots. If you recall, the range is just the difference between the maximum value and the minimum value. And that shows you the overall spread of the data. The interquartile range is the middle 50% of the values. If we wanted to find the interquartile range, we need to use the 5-number summary. The 5-number summary includes the following values: the minimum, the lower quartile, the median, the upper quartile, and the maximum. Let's do a couple examples to warm up. Let's start by just doing a warm-up with this particular set of data. And here I have several numbers. Let's see what we can work with. Okay, so I have the numbers 32, 74, 3, 10, 59, 90, 80, 87, 77, 13, 4, and 33. And just for context, let's just say that these are test scores. I'm just going to pick something. Let's just say these are test scores. Okay. Just for reference sake. I should have put that in context, but oh well, now we have. Okay, so first what I want to do is let's put these in order because this is kind of confusing me the way it is. So I've got the 3, that's going to be really low. Okay, and I've got a 4. Let's see, next number would be a 10. 13 is next. 32? Yeah, it looks like 32 is next. 33. 59. Then 74. Then 77. Then 80. Then 87, and I guess 90. Let's see if I did this right. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values. So n equals 12, and I should have copied 12 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, have 12 values here. Okay, great. So first thing I want to do is write my 5-number summary out. So I've got my minimum, my maximum. Exactly in the middle is the median. I've got my lower quartile here and my upper quartile here. Okay, well my minimum is easy. It's just this one. I'm going to go ahead and switch colors and circle my minimum. So my minimum is really easy. It's here. And my maximum is also really easy. My maximum is this green number right here, and I'm going to go ahead and write it here. All right, so let's divide this data in half and let's see where that is. So I've got 12, so that means that in order to divide my data in half, 6 numbers would have to be on one side and 6 numbers would have to be on the other side. So let's see, 1, 2, 3, 4, 5, 6. So here is half of my data. Okay, whatever number is exactly in between 33 and 59 is going to be my median. What number is that? Well, I could just look at a number line and find it, but then I can also just take the average of those two numbers to find that number exactly. So let's see what the average would be. So I'm going to go ahead and bring my calculator out to help me with that. And I'm just going to average these two numbers, okay? Because remember, the average is going to distribute everything equally. So then the number that's exactly in between is the even distribution. So 59 plus 33, and I'm going to divide it by 2. And I get 46. So the number that is exactly in between 33 and 59 is 46. And I'm going to go ahead and write that in, let's do pink. So the number that is exactly in between here is 46. And I can write it here. Okay, perfect. Now I've got to deal with my lower quartile. I've got to deal with this 50%, and I've got to cut this 50% in half. So since there's 6 values here, I'm going to go 1, 2, 3, and I'm going to cut it right in here, blue. This number right here, right? That partition right here cuts these numbers in half. Perfect. So what number is exactly in between 10 and 13? Well, we can do this again. Clear this out, clear. 10 plus 13 divided by 2. And the number that is exactly in between 10 and 13 is 11.5. Now, the last one I'm going to do is, let's do orange. I don't usually use orange, do I? Okay, the last one I'm going to do is the same thing here in the upper quartile. Here are 6 numbers, 1, 2, 3, 4, 5, 6, and I'm going to cut them exactly in half. Boom. What number is the number that is exactly in between 80 and 77? So let's find that by taking the average of the two again. So here's my calculator. 80 plus 77 equals, divide by 2 equals, and I get 78.5. So the number that is exactly in between 77 and 80 is 78.5. We've got our 5-number summary now, so that completes this part of the question, right? It's done this. Now we have a couple more calculations to do. So let's find the range. The range is the maximum value, and from that we're going to subtract the minimum value. So the maximum value is 90, and if you subtract the minimum value, which is 3, then you get that the range is 87. I'm going to scooch this down a little bit so that we can do our interquartile range. So our interquartile range is going to be the upper quartile, and from that you're going to subtract the lower quartile. So the upper quartile is 78.5 and the lower quartile is 11.5. So if I bring over my handy dandy calculator right here, let's scooch this guy over. I've already got 78.5 here just by chance, minus 11.5 equals, and my interquartile range is 67. Did I answer all parts of my question? Let me just scooch back up here to double check. Find the range. I did that. IQR, I did that. And I'm all done with this problem. This slide has the output from StatCrunch showing the values. Notice that we got the same values. We got the same minimum and maximum. The median was the same. The range was the same. Here, instead of using lower quartile or LQ, StatCrunch uses Q1. and we got the same as them, 11.5. Here, StatCrunch uses Q3 instead of upper quartile, but we got the same value, 78.5, and the interquartile range is 67. If we look at the work that I did on Zite Board, notice that the first time, the minimum and the maximum were super easy to find, right? And then here, dividing the data in half would mean that where this pink line is, 50% of the data is less than this pink line, which is actually the number 46. 46 is the number that is exactly in between 33 and 59. So 50% of the data is on this side of the pink line, and 50% of the data is on this side of the pink line. To find the lower quartile, we took this 50% of the data and divided it in half again. Since we took 50% and divided it in half, now we have 25% of the data in through here, 25% of the data in through here. To find the upper quartile, we took the upper 50% of the data and we divided it in half, and we basically created two more 25%. 25% of the data would exist between the median and the upper quartile, and 25% of the data would be more than the upper quartile. And of course, it includes the maximum. So the 5-number summary splits up the data into 1, 2, 3, 4 pieces, 4 equal pieces. The interquartile range is this spread in through here. This spread in through here represents 50% of the middle part of the data. All right, let's try another example. So this one says, find the range, 5-number summary, and IQR for the following set of data for 17 days of restaurant orders. All right, good job, Taurus. This time you put it in context. Okay, so this time I have, let's count up how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, duh, 17. Okay, so n equals 17. So that checks out here. Perfect. All right, so let's start putting this in order. Hopefully I won't miss any. So we've got a 3. The next highest number is 4. Next highest number, I believe, is 8. We've got a 9. 10, no, we've got 11. Twice. We've got a 16. We got a 17. Got a bunch of 18s. 1, 2, 3. So 1, 2, 3. We have a 20. Is that the next one? Yeah, 20. 22. 24. 27. 38, 39. And let's just double check that I have 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We got them. Okay, so we've got it all. We've got all of them accounted for. Let's go ahead and make our 5-number summary. So I have my minimum, my maximum, my median, my lower quartile, and my upper quartile. Right? I'm going to do my minimum in red, do my maximum in green. I love working with a bunch of colors. I just feel like I don't know. It just makes me happy. I will do my median in pink. All right, so I have 17 numbers, which means that the 9th number will be exactly in the center. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this 9th number means that I should have 8 over here and 8 over here. So 1, 2, 3, 4, 5, 6, 7, 8. And there's my median. That's my median. And I should have 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So this is my median. Now I've got to find my lower quartile. So I have 8 right here. So to divide that in half, I think I used blue. To divide that in half, 1, 2, 3, 4, I need to find the number that is exactly in between 9 and 11, right? Because here's 4 on this side, 1, 2, 3, 4, and 4 on this side, 1, 2, 3, 4, and the number that is exactly in between 9 and 11 is 10. Now I've got to do the same thing up here. I should have 8 numbers up here, 1, 2, 3, 4, 5, 6, 7, 8. I want the number that is exactly going to cut these 8 numbers in half. So 1, 2, 3, 4, that would be, oops, messed it up. That should be orange. Oh, so close. Okay, that number right here. What number is exactly in between 22 and 24? That number is 23. So, all right. So I did my 5-number summary. That's done. Let's find my range. My range is going to be the difference between the maximum and minimum number. So my maximum number is 39, and I'm going to subtract 3. So from that, I am going to get 36 is my range. And my IQR is the difference between my upper quartile and my lower quartile. So my upper quartile was 23, and my lower quartile was 10. So my interquartile range is 13. Yay. Very happy. You know, I'm just going to quickly write the number 10 over here because I didn't mark it. And this one is going to be 18. All right, so there's no questions about what's happening. So let's go back and see if I answered all the questions. I found the range. I found the IQR. So it looks like I'm done with this problem. Here is the output that shows our summary. We have the same range, the same interquartile range, and each one of these numbers between the minimum and the lower quartile represents 25% of the data. Between the lower quartile and the median represents 25% of the data. Between the median and the upper quartile represents 25% of the data. And between the upper quartile and the maximum, that also represents 25% of the data. Within the lower quartile and the upper quartile, there is a spread of 13 units. In this case, 13 orders. So those are the numerical calculations for 5-number summary, IQR, range, etc. But you also can create a visual representation of this data. And in order to do that, we use the box plot. Another name for the box plot is the box whisker plot or the box and whisker plot, but it's comprised of some particular features. It has a box here in the center and 2 whiskers. At times, there will be an outlier, which is represented either by an asterisk or a dot, and we'll get to that later on in another lecture. But this right here, the box, is the whole interquartile range. All of the vertical lines represent the numbers of the 5-number summary. So here would be the minimum value. Here would be the lower quartile, this vertical line. The vertical line right here would be the median. The vertical line right here represents the upper quartile, and the last vertical line represents the maximum. When you're looking at the box of a box whisker plot, the box contains the lower quartile number, the median, and the upper quartile number or value. The vertical line somewhere in the box is the median. It doesn't always have to be in the middle. It can be off to either side. From the lower quartile to the minimum, there is a whisker. Another whisker is created from the upper quartile up to the maximum. Again, the whiskers do not need to be the same length. What we're seeing is how big is the spread between each one of these values. How big is the spread between the minimum and the lower quartile? Sometimes the sides of the box are called hinges, but how big is that spread? There is a larger spread between the minimum and the lower quartile than between the upper quartile and the maximum. Using the same data that we used for example 1, let's try to make a box whisker plot. So first thing you want to do is you want to check to see that you have your 5-number summary. Okay, great. Your minimum is 3, your maximum is 90. Okay, let me go ahead and try to draw a number line here as best I can. And I'm going to see if this works out. I'm going to go ahead and, seeing my minimum is 3, I'm going to go ahead and have this be 0, and I'm going to just go up by 10s to see what happens. Okay, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Not too bad. All right, so this is going to be 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100 out here. Okay, now I'm just going to use these numbers to draw some lines. So first one I'm going to use is my minimum value. I made that one in red. I would say 3 is maybe right about here. Next one is my lower quartile. My lower quartile I made in blue, and 11.5 is going to be probably right about here. My median is 46. 46 is going to be kind of, well, it's going to be kind of in the center between 40 and 50, so I'm just going to kind of make it like maybe right here. My upper quartile is orange, and it was 78.5, so I'm going to kind of draw it like right around here, close, kind of a little bit close to 80. And then the last number is 90, and I have a tick mark for it. Okay, so here I made a line for my minimum, I made a line for my lower quartile, I made a line for my median, I made a line for my upper quartile, and I made a line for my maximum. In order to finish the box whisker plot, I am going to connect these middle 3 lines. So these middle 3 lines, I'm going to do my best to connect them. Getting better and better. Okay, I've connected my middle 3 lines. The upper quartile went through the median all the way up to the upper quartile. So lower quartile to upper quartile, and lower quartile to upper quartile again. Now I'm going to connect my minimum to my lower quartile, and I'm going to connect my maximum to my upper quartile. This is my box whisker plot for test scores. Okay, here I know that I have 25% of the data exists in through here. 25% of the data exists in through here. 25% of the data exists in through here, and 25% of the data exists in through here. Just looking at it, this looks to have more of the data is within the middle 50%. It's not exactly evened out. So you can see that there's a larger spread between the interquartile range. There's a lot of variability within the interquartile range and not a whole lot in the extremes. Let's do the same thing for our other. Let's go ahead and make a box plot for our other example that we did earlier. So here's the other example. I'm going to go ahead and try to make a box whisker plot. Let's see, my minimum is 3, and this time my maximum is 39. So let's go ahead and make increments of 5. So I'm going to go ahead and start at 0 and go 5, 10, 15, 20, 25, 30, 35, 40, 45, and 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay, that'll fit all my values. I'm going to go ahead and make a vertical line where my minimum is. My minimum is going to be right about here. I'm going to go ahead and make a vertical line where my lower quartile is. The median is going to be pink, and it's going to be right about here. My upper quartile is 23, so it's going to be right about maybe here. And my maximum is going to be 39, so it's going to be very close to 40 right here. Let's make my box. Remember, my box is made using these three values. So I'm going to make a box that's going to go through those three. I'm going to make a whisker going from my minimum value to the lower quartile. Remember, this edge is also called a hinge. And I'm going to go from the upper hinge all the way out to my maximum to make the right whisker. Notice that in my right whisker, I have much larger spread. There's a lot going on here. This is much longer than this whisker. The interquartile range looks pretty evenly spread out. So it appears if this is not to scale because, you know, I can't draw things perfectly, but it appears as though that the spread in the center of 50%, the distance from here to here, is not that different than the length of the upper quartile all the way up to the maximum. Do you see what I'm saying? The box, this whole box is about the same as this whole whisker. So there's the same amount of variability in the center as there is in the extreme upper quartile. Calculating the 5-number summary and drawing a box whisker plot is easy when you just have a few values. But if you have a lot of values, it can just become like a total pain to do. So what I'd like to do now is, using StatCrunch, I want to just do a little bit larger set so you can see how we would be able to calculate the 5-number summary using StatCrunch, and then also create a box whisker plot using StatCrunch. So here is the scenario. The scenario is that gas mileages in miles per gallon, MPG, of 4-cylinder manual transmission cars are in a table on the next slide. Okay, and here are 24 values of how many miles per gallon 4-cylinder cars are getting. Okay, so they took 24 cars and they figured out how many miles they got per gallon. So I can take this data. I'm going to go ahead and exit out of my thing. I can take this data and copy it, and then go into StatCrunch, and I'm going to go ahead and open up a new StatCrunch. This time I'm going to type in the title, which is MPG, and I'm going to go ahead and Control V to insert all the values that I just copied off that table. Remember, if you have a Mac, you want to use Command V and it'll do the same thing. Let's go ahead and have the summary stats calculated using StatCrunch. So I'm going to go ahead and select my column, which is MPG, and I want the 5-number summary. I always like to get the sample size because it's important. I hold down Control, or if you have a Mac, you're going to hold down Command. I need the median, I need the range, I need the min-max, Q1, Q3, and IQR. Okay, and I can hit compute, and it will quickly compute the numbers for me. Perfect. Let's make a box whisker plot now. You can just go to Graph, go down to where it says Box Plot, select the variable you want. In this case, it's just MPG. I like to mark the median and the mean. You don't have to. I know that you have a choice of either showing the box whisker horizontally, or you can also show it vertically. We've been doing all the examples horizontally, so I'm going to go ahead and click that too and hit compute. And now I have a box whisker plot just like I needed. And I can kind of play with the size just by seeing how these little arrows can kind of play with the side, and it's really nice because it also puts down the title right here, which you should always do. So in this case right here, we can see that the median, which is 32, is not in the center of the box. Okay, we can see that the whiskers are approximately equal length. It looks like this right whisker is a little bit longer. Notice this is the mean because the mean is green. Although we didn't talk about mean in this lecture, when we were talking about measures of center in the last chapter, remember that when the mean and the median are not the same, they're a little bit different, it means that there's something off in the direction of the mean that's pulling at the mean. So there's something out here that is pulling this mean just a little bit far away from the median, okay? And that might also account why this whisker seems to be just a little bit longer than the other one. I'm not sure. Just if it is longer, it's a very slight thing. Okay, so 25% of the values would exist in through here. 25% of the values would exist between the edge of the box, the left edge of the box, to the red line. 25% of the values would exist between the red line, the median, and the upper quartile, and 25% of the values would exist between the upper quartile and the maximum. So what makes it nice is if you had, for example, 9,000 values, right, you're not going to start trying to figure out where the half of that is. You use technology, but you have an idea of what the technology is giving you, what information it's giving you. Yes, it gives the calculations. It's very easy and nice to do, right? Nobody wants to do a whole bunch of calculations for a whole bunch of numbers. And it gives you a very nice box whisker plot. Nobody wants to make all those number lines and start making box whiskers by scratch. But you have to be able to interpret what this information means. As always, I've linked the Google Slides in the description box below. If you go through the remainder of the Google Slides, you will see that it's just the manual calculations, finding the minimum, lower quartile, median, upper quartile, maximum, showing how it's dividing it into quartiles or fourths, and how each quartile represents 1/4 of the data. And also it goes through making the box plot step by step. So what's the big idea? Today's big ideas are that the 5-number summary splits the data into 4 equal parts. 25% of the data lies between each quartile, and that the interquartile range describes the variability of the middle 50% of the data. The box whisker plot, also known as the box plot, displays the 5-number summary visually. The vertical lines represent each value of the 5-number summary. The box is the IQR, and the whiskers describe the spread between the extreme values, the spread between the minimum and the lower quartile, and the spread between the upper quartile and the maximum value. So that's it for today. With that said, don't forget to check your emails, check Blackboard, do your homework, and subscribe to this channel. Even better, hit that notification bell so you know when there are new ideas for this course. Okay, this is your teacher, Torres, saying stay safe, and I will be waiting to give you a virtual elbow bump in the next video. Ciao!